Good afternoon, everyone. My name is Mr. Nakvi. I am your teacher of computer science at Edgar Wood Academy. Now, before I get started, I thought I'd like to introduce the topic of computer science to you as my students. Now, what is computer science? A lot of people think it's a very complex method of problem solving, computational thinking, and understanding computer systems and how they work. Now, there are very, very different components on the computer science module that we will be covering over the period from year 7 all up to year 11. That is, if you do take the option in year 9 to study computer science. And before I get into the topic, I just thought I'd share some insight into computer science, types of jobs that are available, and when you would be required to use the fundamental knowledge that I will be teaching and delivering in the classroom, as well as the types of jobs that are available and when you'll be using those principles in action. Now, I'm going to explain the different sections that make up the computer science topic and the two types of papers that are going to be tested upon yourselves as students to understand, deliver, and show your skills in coding. Now, the first section is algorithms. Algorithms, what are they? Algorithms are used to solve a problem for a certain challenge. Now, the types of algorithms that we'll be looking at throughout the year are writing algorithms such as pseudocode, flowcharts, warm-up and worked exam style questions, as well as search algorithms, sorting algorithms. But before I explain further into that topic, why do we need algorithms? Now, let's say there is a company in the real world and a company needs to solve a problem. Now, we use algorithm to solve a problem. Now, companies typically look for people that can code and write a programming language that a computer can understand and solve a problem. Now, if you are into programming, we will be learning in Edgar Wood Academy, we will be learning Python programming from year 8 up to year 9, and then year 9 you'll have the option to choose computer science. If you do wish to choose computer science, you'll be going into more advanced Python programming and more logical thinking in terms of real life scenarios, and that's to not only gauge your understanding of the subject but also open your mind into exploring new avenues and areas that relate to computer science and Python programming. From the get-go of year 7, we'll also be looking at programming. Now, we're going to start off with the very basics: sequence, selection, and iteration. Sequence is like a set of steps followed in order to complete a process. Now, a sequence can be, for example, baking a cake, making a cup of tea, making a piece of toast. They're very basic examples of real life day-to-day things that we do and we don't realize we're doing them. That is known as a sequence. Selection is making a choice, decision or a choice. Now, that decision can be true or false, yes or no. Now, that is known as selection. The next step is iteration. Iteration is when you repeat something over and over again in order for you to get the outcome that you want. We will also be looking at Boolean operators, random number generation, arrays, records, subroutines. Subroutines are used to basically break down a problem into smaller chunks, making it more easy and more effective when coding. Subroutines are used specifically to do a task and it uses less code in the program. Now, based on these two topics, algorithms and programming, they are ideally suitable for someone who is looking to go into a programming role, specifically front-end, back-end web development, or games design. Now, why do we need programming in games design? Algorithms. For example, if we want to write an algorithm to code a character to move forward, left, and right, and repeat a certain action multiple times, like for example a game of Fortnite, characters running around on a map, we're using algorithms by writing them and solving a problem for allowing a user to move a character in a game. Now that is a real life example of where you'd use algorithms and programming. Now the next section we'll also be looking at is design and testing. Design and testing is a core principle in computer science as well as a real world application. Let's say you're working for a company and you're in a project management team and they are looking to create a new product or service to market. Design and testing is the very final phase of a delivery of a product or service to a market. Now, what do I mean by that? Let's say we have a product. The product is a game. We want to create a game for a user, and the user has to collect a certain number of items, which then increases their score and unlocks the next level. In this, we have different types of design and testing. Why do we need design and testing? Design and testing is needed so that we can understand, as not only the designers, but also the users who are going to be playing the game, does the game work? Are there any bugs? Any problems? Any glitches? Are there any issues that have not been detected in the game? Does the game work fine on all platforms? These are known as design and testing phases. But if I was to go into more advanced, they're known in the business world as alpha testing, beta testing, gamma testing. Alpha testing is the very first stage of testing, and then you have beta testing. Once the alpha has been approved, you move on to the beta testing. Once the beta has been approved, you go on to gamma testing. Gamma testing is what's needed at the very last stage of any game design or any product or software service design before launch. The next topic in the computer science module is known as data representation. How do we see data, and how does a computer see data? Now, a computer sees data different. Now, if I was to type in the number 1 into the computer will read number 1 as 000000001. Whereas if I type the number 1 by hitting the keyboard, on the keyboard the key number 1 will be displayed on the screen, whereas the computer would read it differently. And that is known as binary and denary, and also hexadecimal. These are things that we'll be looking at as well. We'll also be looking at characters, storing images, storing sound, compression, encoding data, and the different forms of units. That is just known as binary and denary. We also look at decoding messages, which was used in the World War, known as Morse code, but now currently known as ASCII. ASCII is using characters from the alphabet A to Z, from capital letters to lowercase letters, as well as special characters such as the exclamation mark, the semicolon, the pound sign, the at sign, the dollar sign, the percentage sign. These are all known as special characters, and these are ways for us to write decoded messages, for others to decode and try and work out what we have written using ASCII. Now, why do we need to use decoding or learn binary and ASCII in data representation? Data representation is a big field in industry, and if you're looking to work as a business analyst, a data analyst, or for example you are looking at a program that's been written and you're looking for faults, you can get paid a lot of money for finding faults for companies by analysing data, seeing where the problem is and finding it, and then fixing it. The next topic is computer systems and databases. Computer systems, what are computers made up of? What do they comprise of? How do they function? We also have system software. What types of software are out there? Operating systems such as Windows, Linux, Mac. We also have databases. Why do we need databases? Why do we need to know how databases work? Such as a database example is SQL. Now, SQL is a database that is widely used in the business world and in the real world by major corporations to manage and handle data. Now, why would we want to study computer systems and databases? Computer systems and databases is a key fundamental topic to study if you want to become an ICT technician, an IT ops manager, operations manager. You want to become a first line, second line, or third line support engineer, an IT analyst, or a computer systems engineer, or you would like to be a database engineer, a database tester, database analyst, database creator, a MySQL database engineer, and you can also be a computer systems repairer. These are all jobs that fall into section 5 of the computer science topic. So if that is what interests you as students, as my students, then please come to me, and I can also share real life experience that I have done in industry working around those job roles. Now topic 6 is networks. Why do we need to know about networks? What types of networks there are? There are local area networks, wired area networks, wireless area networks. We also have network topologies, the types of topologies available. We have star system, bus system, ring system, and also how to solve a problem with a network. What kind of network topologies or structures are needed in the real world, and what would we find if there was a network issue? Now, the topic behind this networks is finding out how networks work, but if you are interested in pursuing this as a career, the types of jobs you can find through networks are a network engineer. You can have a server manager. You can also have a server tester. You can have a network engineer that works on coaxial cables, Cat6e, Cat5e cables, and these are different types of cables. You can also be a broadband engineer. You can also work engineering for a aerospace agency. You can also work in the military, and you can also work as a network designer. So that's someone who comes up with the infrastructure, the design of networks for small, medium, and large scale organizations. Another insight I want to share with you guys is with networks, if you were to pursue a career in networks, you'd have to get certain qualifications. Now, I didn't mention this in section 5, so let's just start with section 5 to go back on, and then we'll move to section 6. So section 5, if you are interested in computer systems and databases, you can get a certificate in MySQL. You can get a certificate in CCENT, which is a Cisco certified entry-level network technician. You can also have a CCNA, which is a Cisco certified networks and intrusion. You can also have network and firewall, which falls into section 6 networks. If you have, for example, you went and studied computer science, you left Edgar Wood Academy, and then you went on to study computer science or computer systems at college, and then went from college to university and did a bachelor's degree in the subject, and then you're trying to look for your first job, the best recommendation I'll give you as a teacher is to take the CCENT exam. CCENT is widely recognised throughout the world in major corporations. The exam takes 6 months to complete, and upon completion you get a certificate with your name on to say you've done the basic entry of Cisco's Certified Entry-Level Network Technician exam, and you can get hired at a job that pays between £24,000 to £30,000 a year. If you were to take on the CCNA exam and you passed, you will also get hired as a network engineer for any company that uses Cisco, which are the network servers and the routers and switches. You can get hired between £30,000 to £45,000 depending on experience, and the more experience you've got, the more chance you'll have of getting higher pay in industry. If you have the Cisco firewalls and security, you can get paid between £40,000 to £70,000 depending on location and experience. Now lastly, the computer science topic covers ethical issues, legal issues, environmental issues. These are things that would cause harm to society or around us based on software and technology that we are implementing into the world. These are very, very forward-thinking, straightforward answers. They're not very complex, and this also grasps the students' minds to understand the topic of computer science, not only the peripherals and the design behind the actual topic itself, but also the issues that you could face, whether it is you're working for a company or you've got your own company that you would like to start up and initiate in the world. How would that impact ethically, legally with other companies, and environmentally? What impact would it make on society as a whole? This is a very interesting topic and can open up a lot of classroom debates. Now, if you found this interesting or would like to speak to me, please come to my office, which is in the computer science room. There are 2 rooms. I'll be in either or room. You can come to me, ask me any questions, ask me about advice in terms of computer science itself, the topic, what jobs are available, as I have quite a lot of connections outside of the school within industry. And also I'd like to share something with my students. Now, I would like to share that I have worked in industry over 13 years, combined experience working with some of the largest corporations in the world. I've worked with Microsoft, Oracle, Cisco, Amazon Web Services for cloud computing. I've also worked with major brands such as Jaguar Land Rover. I've also worked with Ferrari. And I've also worked with Aston Martin as well. And there are several other companies that I have worked with. Now, why did I become a computer science teacher? The reason I became a computer science teacher is to inspire the students that I teach, the people that are surrounded every day around me, from the youth to people the same age as me or older. Now, why do I want to do that? Because in life, knowledge isn't free, not all the time, but when you put in the action and you learn and you implement what you've learned and you've filled the role and responsibilities of someone who has worked in the tech space like I have, wouldn't you want to share it with others so that they can do the same at a younger age and not fall down the paths or the pitfalls of not only entrepreneurship or business, as well as being misguided the wrong way, and not getting what you want.